Greetings to all. In today's session, we are going to discuss about international chemistry, where on the international platform you can prepare for any entrance examination or else any competitive exam you are aspiring for. This kind of session will be very much helpful. In addition to that one, India level JEE Advanced and JEE Mains examination and NEET chemistry, which is the medicinal entrance examination. In addition to that one, Telangana EAMCET and Andhra Pradesh EAMCET examination for technical education into the engineering stream. So in addition to all these, if you are preparing for any kind of competitive examination towards government job, so that this session will be very much helpful, where we collected all different kind of questions from the previous year question papers and a detailed explanation is provided over here. I will assure for the quality content over here in order to crack whatever you are aspiring for. So let's enter into our today's session. Question number 1, it is given from the IUPAC nomenclature. The long chain organic compound is provided in accordance with the International Union for the Pure and Applied Chemistry. We have to give the numbering and we have to assign the exact name of this compound, right? So here the condition is, if you start from right hand side, you can go with one of the carbon over here, or else there is any other possibility you can start numbering from left hand carbon as well. But here bromo is there, here methyl is there. Bromo will obviously get the higher priority over methyl, so that numbering will be started from the left end. So if you are starting numbering over here, first carbon is accommodated with the double bond, second carbon with the methyl, third, fourth, fifth carbon is having side chain substituent with the 2 carbon chain with either fluoro over here. This is the branch. 6th, 7th, 8th. 8th carbon is having 1 carbon with the iodo substituent over here. 9th carbon is having methyl. 9th carbon is having double bond as well. 10th carbon and either methyl. 11th carbon is there. So if you see this, so many possibilities are there, but the compulsory condition is longest chain is considered to be a parent chain. So that let's go with the 1, 2, 3, 4, 5, 6, 7. If you go with the numbering like this, 7 carbon chain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It will be the 11 carbon is the longest chain, so that this will be the order where you can assign the naming. Let's go how to name this compound as per IUPAC nomenclature. Right here, first of all, we have to assign what kind of configuration you have over here. So here, if you observe, geometrical isomerism plays a role over double bond arrangement, so that bromo will be there. If nothing is mentioned, indicates here either hydrogen will be there, hydrogen bromo, so that bromo will be the most priority group. And here methyl is there, here CH2 is there, so that CH2 chain will get the priority. One is assigned for bromo, one is assigned for this methylene. One are arranged in the same side of the double bond, so that we can assign one Z. Z means this arrangement to higher priority or at the same edge, right? So this will be the 1Z meaning, which is a geometrical isomerism. And the first carbon is having bromo, second carbon methyl. So let's give first carbon bromo. 1 bromo will be taken. So second, third, fourth, fifth. Fifth carbon is having another substituent, so that it can be mentioned in the bracket. So on fifth carbon, so that mentioned with the 5. So here side chain, if again numbering is given, first carbon with the fluoro, 1 fluoro, and here chain length is 2 carbon, so that ethyl is mentioned. If you move on 6th, 7th, 8th, again 8th carbon is having side chain where carbon accompanied with iodo. So 8 square bracket, iodo methyl we can say. Being it is the 1 carbon, meth is the prefix. So iodomethyl can be taken over here and followed by 9th carbon is having double bond, 9th carbon is having methyl, 10th carbon also having methyl. If you count all methyl over here, 2nd, 9th, 10th carbons are having methyl, so that we can say 2, 9, 10 trimethyl. And being 11 carbon chain, we have to assign undeca, right? Decane is 10 carbon chain, undecane is the 11 carbon chain. Andeca is the suffix over here, and we can give the numbering for double bonds. Double bond is there on the first carbon and the ninth carbon as well. 1, 9 diene. This will be the entire naming of the long chain organic compound with the different substituents over here, and as per the IUPAC regulations, naming will be provided like this. Let's go with another question number 2, where solid state chemistry is provided for the central metal arrangement. So if this is the arrangement which is called a primitive cube, in this P, Q are provided. P is mentioned with the positive, Q is mentioned with the negative ions. So P plus and Q minus will be there. And this is the arrangement called a simple cubic. What's the question? Two elements P and Q are in the same period of the periodic table. Both belongs to the same period. PQ react together to form the ionic compound. It is the example for the ionic compound. Part of the lattice of this compound is shown, right? So it is the lattice which is provided with the simple cubic geometry. So as per this arrangement, some of the statements are provided. We have to depict which is the correct one. In an ion of P has a more electrons than ion of Q. As it is mentioned, P is with the positive, Q is with the negative. Being both are present in the same period, so that we can say P is losing electrons, Q is gaining electron. We can't say more electrons are accompanied with P because of electropositivity. It releases electrons and electron density got slightly lowered. So option number 1 will not be the correct statement for this kind of primitive simple cubic. Element P is non-metallic. As we are aware, any kind of species is becoming positive. All the metals are electropositive in nature. Very rarely, non-metals are able to give the positive, but it is not that much common thing, right? So that we can say element P is non-metallic is absolutely wrong. So all metals are electropositive. If we see this is called electrochemical series. If you see potassium, it will lose the electron. Calcium also having tendency, sodium, magnesium, aluminum, zinc, iron, nickel. Any kind of metal having natural tendency to lose the electron to get the electropositivity. So that we can say, so element P is non-metallic is absolutely wrong. So P will be the electropositive, and being it is metal, so that positivity is assigned for this one. Another one, P is to the left of Q in the periodic table. So in order to get the ionic compound, the condition is electropositive elements will reside in the S block. Electronegative elements will be resided in the P block. That's the reason why left hand side in the periodic table, we can find the metals of S block elements which are electropositive in nature, and Q is the element in the right hand side with the non-metallic nature having seeking of electrons. So that option number C will be the correct one in order to understand this one. The formula of compound is P4Q4. P4Q4 is given. Let's see whether it is correct or not. Right. So if you see this, electropositivity is there for the metals, and a simple cube is assigned like this for simple cubic. So where atoms are located, atoms are resided only in the corners, nothing else. Only in the corners you can find the atom. That's the reason why we can say 8 atoms are there, and each corner always contribute 1/8 of the atom. So 8 can be multiplied with 1/8, so that 8 get compatiated. We can get only one atom for the species, right? So we can't say P4Q4. Only the correct word will be P is the left to Q in the periodic table. This is for question number 2. Option number C will be the right answer. Let's move on to question number 3, where you have to go for list 1 and list 2 compounds. Purely it is from the inorganic chemistry. Oxoacid topic, oxoacids of sulfur are provided. All these are regarded as the oxoacids of sulfur. So when you consider all these, if you know the exact geometry of the compound, so that it is very simple to depict what are the list 2 elements which are mapping with the list 1. Oxoacids of sulfur, and what kind of bonding will be there to be mapped. Peroxo disulfuric acid. It's very obvious that peroxo bond is nothing but whenever oxygen directly linked with the single bond is called a peroxo. That is only available in the option number 3. Sulfur oxygen sulfur bond is there, and moreover you can find oxygen single bond, so that peroxo. A can be mapped with 3. The same manner, let's see the entire geometry of peroxose disulfuric acid, where you can find S double bond O double bond O OH, oxygen. This is called a peroxo. Moreover, dimer form will be there. This kind of species fragment existing left side, exactly resembling with the right side, so that we can say it is the disulfuric acid. Fine. Disulfuric acid with the peroxy linkage, hence we can say peroxy disulfuric acid. This will be the compound number 1. If you see the B, sulfuric acid is the H2SO4 is called king of the acids, where you can find the geometry in this manner. H2SO4 S double bond O. Here OH, here OH will be there. This is called a sulfuric acid. 2 OH will be there, 2 OH are provided, 2 S double bond O is there. 2 OH and 2 S double bond O are rightly preferred for sulfuric acid, so that B can be easily mapped with the option number 4. Let's go with pyrosulfuric acid. Pyrosulfuric acid is geometry is assigned in this manner. Pyrosulfuric acid, we are having, you can put sulfur over here, sulfur over here, so that you can find a double bond O OH OH will be there. In that case, you can find 2 SOH bonds are there, 2 SOH bonds will be there, and 4 S double bond O, 1 SOS bond can be found for pyrosulfuric acid, right? So pyrosulfuric acid, let's see once. How can we find the pyrosulfuric acid? We will go with that. Pyrosulfuric acid is accorded with the sulfur ether linkage will be there, and you can find double bond O. 4 S double bond O bonds will be there, and here OH and here also OH will be there. 2 OH, 4 S double bond O, 1 ether linkage can be found over here, that is provided. Here, if you see, 2 SOH bonds are there, 4 S double bond O bonds are there, 1 SOS bond is there. This will be called pyrosulfuric acid. If you go with sulfurous acid means sulfuric acid is H2SO4. Sulfurous acid means 1 oxygen is less, so that we can say H2SO3. In that H2SO3, what difference you can find? 2 SOH bonds will be there. 2 SOH bonds will be there. Instead of 2 S double bond O bonds, you can find only 1 S double bond O bond, because shortage. Sulfurous means 1 oxygen less. Instead of 2 S double bond O, you have to find 1 S double bond O, so that D will be mapped with 2. Okay, sulfuric acid is 2 SOH and 2 S double bond O. Sulfurous acid will be 2 SOH and 1 S double bond O will be there. That is given here, S double bond O, OH, which is called a sulfurous acid, right? So by this, entire mapping of oxoacids of sulfur with their skeletal bonds will be provided here. Peroxo means oxygen single bond. Sulfuric acid means H2SO4 can found option number 2. Pyrosulfuric acid, where you can find SOS means ether linkage can be there. SOS bond is called pyrosulfuric acid. Sulfurous acid, where one of the oxygen is less than sulfuric acid, that will be two SOH and one S double bond O will be there. This is the right mapping for the question number 3. Let's go with the question number 4. What fraction of one edge-centered octahedral void lays in one unit cell of FCC? FCC denotes face-centered cubic. It is the solid-state chemistry around the central crystal lattice. Okay, so crystal lattice will be there in that. FCC denotes face-centered cubic. If you consider the octahedral voids, so what fraction of one edge-centered octahedral void lays in one unit cell of FCC? In order to calculate that one, first of all, we have to see FCC geometry. In the face-centered cubic geometry, 1, 2, 3, 4, 5, 6, 7, 8. And here 8 corners will be there. Apart from that, 6 faces will be there. Number of faces are 6. Top face, bottom face, left face, right face, back face, front face. This is the way you have to mention 6 faces over here, right? 8 corners and 6 faces are provided. And moreover, coordination number for this kind of face-centered cubic will be 12, right? So coordination number means the number of bonds around the central atom is said to be coordination number. That is provided with the coordination number 12. And the metals including aluminum, copper, aurum, lead, nickel, platinum, silver, are able to give the geometry of face-centered cubic. In order to count the number of edges, 4 atoms are present. For the unit cell, 6 phases are present over here. Each phase contribute 1 by 2. So that 6 phases into 1 by 2 plus number of corners are 8. 8 corners into 1 by 8. 8 corners into 1 by 8. 8 compatiated. 2 3s. 3 plus 1. Number of atoms are 4. So 4 atoms are going to contribute over here. And 1 by 4 is the correct answer for question number 4. For question number 4, option number B will be the correct answer. Let's move on to another question, question number 5, where again mapping of list 1 with the list 2 are provided. This is the question given from amino acids. Okay, it is related with the bioorganic chemistry. All these are called amino acids. This is the glutamic acid, lysine, valine, tyrosine. These amino acids, if you know its geometry, it's a chemical composition, then what kind of category they belongs to, we have to assign. Glutamic acid can find. First of all, we have to know, before entering into giving all the geometry of the compounds, first of all, what will be the skeleton of amino acid? Amino denotes NH2, acid denotes COOH, right? So in that amino acid, you can find NH2, COOH as a common components. Okay, in general, all amino acids are alpha amino acids, right? So whenever alpha amino acids are considered, in that glutamic acid is having one additional COOH, so that it will be acidic. Lysine is having one additional NH2, so that it will be basic. Valine is a one NH2, one COOH, both will be compatiated neutral. Tyrosine is the amino acid containing benzene ring, so that we can say aromatic. Okay, so let's see the detailed geometries of all kind of amino acids provided in this statement. If you see, glutamic acid is observed here. NH2 will be there, COOH will be there. This is the amino acid with the alpha position. And another terminal is also having COOH. COOH are 2. COOH belongs to acidic. NH2 belongs to basic. So one acid, one base get compatiated. One additional COOH will impart acidic nature. Hence, we can say it is acidic amino acid. If you see the second amino acid, lysine, where NH2 base, COOH acid, both get compatiated. This will compatiated. But in addition, we have one NH2. NH2 will impart a basic nature. So that lysine is the basic in nature. So basic amino acid, Kshara amino amlamu. And another valine. Valine is the neutral one, where you can find one COOH with one NH2. And the side chain is the isopropyl. So that we can see neither acidic nor basic, rather it will be the neutral, because nature of base compensated with one nature of this carboxylic acid. Hence, valine is the neutral one. Neutral is also there, tatastha amino amla. Let's go with the last one, where benzene ring will be there with the side chain CH2C, NH2COOH, right? So if you see this, NH2COOH is becoming neutral, but the condition is aromaticity. Here you can find phenol. And this phenol, because of phenol, presence of phenol, it will be an aromatic amino acid. So tyrosine is the part of aromatic amino acid. D can be mapped with option 1, aromatic amino amlam. Right? This is the way we have to map all the options given for question number 5. Glutamic acid is the acidic one, lysine is the basic one, valine is the neutral one, tyrosine is the aromatic one. The last question of the session, again it is the part of bioorganic chemistry, carbohydrates. Carbohydrates are the compounds which are giving energy to the living organisms when we are consuming. Energy source are carboxylic acids, carbohydrates only. Among carbohydrates, you can find monosaccharides, disaccharides, trisaccharides, oligosaccharides, polysaccharides based on the number of sugar molecules got combined, number of sugar moieties got combined. If only one unit is there, that is called monosaccharide. If 2 units got combined, we can say disaccharide. Oligo means some extent up to 20 carbons, 20 saccharides, 20 sugar moieties got combined, called oligo. If more than 20, if you see, that is called a polysaccharide, right? Dextrose is a polysaccharide. Our table sugar is the sucrose, is the disaccharide. So in the same way, here also we have disaccharide lactose. This lactose is the milk protein. In the milk, you can find this lactose. Upon hydrolysis of this lactose, there is a formation of galactose and glucose, right? Disaccharide lactose on hydrolysis forms galactose and glucose. During this hydrolysis, which enzyme is take part over here? The enzyme used in this hydrolysis of disaccharide lactose into galactose and glucose. There are certain options. One is called lactase, second is called permease, third is called trans-acetylase, fourth is called beta-galactosidase. Let's see which is the correct one. Beta-galactosidase is the right answer. In order to get this one, if you see this, this is called a disaccharide, where 2 sugar moieties joined with the ether linkage. This is the lactose milk protein. This milk protein got hydrolyzed. If you add water in order to cleave the bond over here, water will be added so that 2 moieties got separated. One is the galactose, second is the glucose. In order to hydrolyze, we need to add one of the enzyme that is called beta-galactosidase. So that the right answer for this disaccharide lactose hydrolysis will be beta-galactosidase, right? For question number 6, option number 4 will be the correct answer. By this, we completed the entire session. All these belongs to the recent exams whichever performed in international, national, and the state level examinations on the various platforms. Hope this session will be very much helpful for your aspiring preparation towards any contemporary examinations. So I'm requesting you to kindly like the channel, comment which part is favorite for you and where you enjoyed this kind of video while explaining the things over here, and share with the aspirants whoever seriously preparing for the examinations in order to achieve their goal, and subscribe the channel in order to get more such videos, and it will be the kind of encouragement to get more content over here. And thank you very much for your patient listening. Thank you one and all.